Good afternoon students. Welcome to your mathematics class. Today in this video you will learn about the chapter integers. You have already learned about natural numbers, whole numbers, integers in your earlier classes. In this chapter you will learn more about integers and the four basic operations, that is addition, subtraction, multiplication and division on integers, and also the various properties on integers. Let us recall some important points. Natural numbers. We know that the counting numbers 1, 2, 3, 4, 5 and so on are called natural numbers. The set of all natural numbers are generally denoted by the letters capital letter N. So N is equal to 1, 2, 3, 4, 5 and so on. This dotted shows that there are infinite numbers of natural numbers. So from this we can say that 4 is a natural number, yes. Also if I write 35, yes, it is also a natural number. So in short we can write 35 belongs to N. That means if I write in this way, it means that 35 is a natural number. Now if I write suppose 0.2 or if I write 0.02 or 2 by 5 etc., then these are not natural numbers because these numbers cannot be counted as a whole. So they are not natural numbers. Now if we add any two natural numbers, for example 3 plus 10, it will give 13, which is again a natural number. So sum of any two natural numbers is always a natural number. Similarly, if you multiply any two natural number, for example 3 multiplied by 5, it's coming here 15. So product of any two natural numbers is always a natural number. But in case of subtraction, if we subtract any two natural numbers, then the result may be or may not be a natural number. For example, if I write 6 minus 2, it will give 4. We know 4 is a natural number, but on the other hand, if we write 2 minus 6, so there's this result is not defined in the set of natural numbers. So subtraction of two natural numbers may or may not be a natural number. Similarly, in case of division, division of two natural numbers may or may not be a natural number. For example, if we write 6 division 2, then it will come 3. So, but 2 division 6 will not give 3. So, that is not defined in the set of, that number is not defined in the set of natural numbers. So, division of two natural numbers is numbers may or may not be a natural number. Now, when a natural number is subtracted from itself, we get a number 0, which is not defined in the set of natural numbers. Thus, we can say that all natural numbers together with 0 are called whole numbers, and it is generally denoted by the capital letter W. So, W is equal to 0, 1, 2, 3, 4, 5 and so on. This dotted shows that there are infinite numbers of whole numbers. Also, we can say that every natural number is a whole number, but 0 is a whole number which is not a natural number. As in the case of natural numbers, we can say that addition and multiplications of whole numbers always give a whole number, but subtraction and division of two whole numbers may or may not be a whole number. Also, division by 0 is not defined. If we subtract a whole number from another whole number, then the result may or may not be a whole number. For example, if we subtract, for example, 3 minus 2. If we subtract 2 from 3, then we get 1, which is a whole number. If we write 7 minus 4, we get 3, which is again a whole number. But in case if we write 2 minus 3, then this result is not defined in the set of whole numbers. Similarly, if we write 4 minus 7, then this result is also not defined in the set of whole numbers. Thus, we need to extend whole numbers in such numbers as -1 called -1, -2 called -2, similarly -3 called -3, and so on, such that 1 plus -1 is equal to 0, similarly 2 plus -2 is equal to 0, 3 plus -3 is equal to 0, and so on. So, the set of whole numbers is extended to another system of numbers called integers. So, a collection of all whole numbers and negative values of the natural numbers is known as integers. Integers are generally denoted by the capital letter I or Z. So, Z is equal to under bracket, the dotted from the left hand side, then -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. So, both the sides dotted shows that there are infinite numbers of integers. So, this integers is also represented on the number line. You can see here, it is shown here. In the middle, the number 0 is there, which is 0 is also an integer, which is neither positive nor negative. After that, 1, 2, 3, 4, 5, which is also known as natural numbers. Also, we call them as positive integers. So, to the right, the numbers to the right of 0 are called positive integers. And in the left side of 0, the numbers are called -1, -2, -3. These numbers are called negative integers. Or we can also say that negatives of natural numbers. So, in this way, we can represent integers on the number line. Suppose if it is asked, show the number 5 on the number line or -3 on the number line. So, we just mark this point. This 5 point shows the integer 5 on the number line. Similarly, here -3 is on the left side of 0. So, we mark a circle over it. So, this point shows the integer -3 on the number line. So, in this way, we can show the integers on the number line. The numbers 1, 2, 3, 4, 5 and so on, which are greater than 0, are called positive integers. These numbers are to the right side of 0 on the number line. The numbers ... -5, -4, -3, -2, -1, which are negatives of counting numbers 1, 2, 3, 4, 5 and so on, are called negative integers. All negative integers are less than 0 and to the left side of 0 on the number line. 0 is an integer which is neither positive nor negative. So, we can say that all positive integers are greater than 0 and to the right side of 0 on the number line. All negative integers are less than 0 and to the left side of 0 on the number line, and 0 is an integer which is neither positive nor negative. Thus, we can say that integers have either a positive sign, that is plus, or negative sign, that is minus. These two signs define their direction or position on the number line. Integers are also known as directed numbers. On a number line, the value of integer increases as we move right to the number line and decreases as we move left to the number line. You can see one example here. For example, if I write 3, then 4, then 5. Here 4 is greater than 3 because 4 is to the right side of 3 on the number line. But similarly, 3 is less than 5 because 3 is to the left side of 5 on the number line. So, in this way, we can easily, by observing the number line, we can easily say that the which integers is greater and which is smaller. Now, for finding the greater or smaller of the two integers a and b, by observing the number line, so if a is to the right of b on the number line, then we can say that A is greater than B. For example, so if I write 1 and 2, here 2 is to the right side of 1, so we can say that 2 is greater than 1. Similarly, if A is to the left of B, then A on the number line, then A is less than B. So here 1 is less than 2 because 1 is to the left side of 2 on the number line. Now, if A is equals to A equal to B means if A and B are at the same point. So, two integers are said to be equal if they are lying on the same point on the number line. Now, what is absolute value of an integer, which is also known as modulus of an integer? The absolute value of an integer is its numerical value regardless of its sign or direction. The absolute value of an integer p is denoted by mod p, that means which is read as mod p, and is defined as mod p is equals to plus p if p is a positive integer, or 0, and minus p if p is a negative integer. For example, absolute value of 6 is equal to 6 because 6 is a positive integer. Absolute value of minus 6 is equal to minus of minus 6 because here absolute value of negative integer is minus p. So here we put one minus, so it becomes 6, and absolute value of 0 is equal to 0. Thus, the absolute value of an integer is always positive. The absolute value of 4, that is mod of 4, is 4, and the absolute value of minus 4, that is mod of minus 4, is also 4. So minus 4 and 4 both have same absolute value equal to 4 as they are equidistant from 0 on the number line. Therefore, the distance of any number from 0 is called its absolute value. So, the integers having same absolute value are known as opposite integers. Now, to find the distance between any two integers, say x and y, we subtract them in any order and take the absolute value of the result. So, if x is greater than y, then first we find x minus y, and then we find mod of x minus y, which gives the required distance between the two integers x and y. So, to find the distance between integers minus 19 and minus 30, here minus 19 is greater than minus 30. So, the distance between the integers minus 19 and minus 30 is given by modulus of minus 19 minus of minus 30. As minus multiplied by minus becomes plus, so it is minus 19 plus 30. So, if we subtract 30 and 19, then we get here 11. So, it will come 11 units. Now, let us do one example. The ascending order of integers minus 7, minus 1, minus 3, 0, minus 2, 8, 3, 12 is what? So, first we write all negative integers separately, then all positive integers separately. After that, we arrange them. So, negative integers, all negative integers here, whatever is given. The negative integers are minus 7, minus 1 and minus 3 and minus 2. These 4 are given, and just we arrange these negative integers in ascending order. So, first we will write minus 7, which is the smaller one, then minus 3, then minus 2, after that minus 1. Similarly, we write the positive integers. First we write all positive integers. So, here first positive integer is 8, then 3, then 12. Now we arrange them in ascending order. So, the smaller one is 3, then 8, then 12. Now we combine this negative integers and positive integers, and we place 0 between them. So, first we write the negative integers in ascending order, that is minus 7 less than minus 3 less than minus 2 then less than -1. After that there is one 0, so we put one 0 here, because 0 is neither positive nor negative. Then we put the positive integers 3, then 8, and then 12. So in this way we can put this fill in the blanks, that arrange the ascending order of integers. So here we write first -7, then -3, then -2, then -1, 0, 3, 8 and 12. This is the ascending order of given integers. So in this way, if it is asked for descending order, then first we write the negative integers, then we arrange them in descending order. After that positive integers, then we arrange them in descending order. After that we write it in the then we combine the two integers. So in this way you try some questions which is given in your book. I hope all of you understood about what do you mean by integers. So thank you all of you and have a nice day.